There's this common idea about learning languages that I think we've all secretly had at some point. It's like the Jason Bourne fantasy.
The Jason Bourne fantasy.
Yeah, the idea that once you learn a second language, the floodgates just open. You're a polyglot now.
Right.
Your brain just gets it. You figure learning a third language is just like the second, only, faster, easier, and with a lot less crying over grammar tables.
It's a very appealing idea that you eventually just unlock some kind of universal language code in your brain.
Exactly. But for today's deep dive, we're looking at a stack of research that suggests the reality is, well, it's a lot messier and honestly, a lot more interesting.
It really is.
We're looking at third language acquisition, or L3, and the sources suggest that when you go from 2 languages to 3, your brain isn't just getting better at it, it's actually facing this unique, almost chaotic computational problem.
Nightmare might be a bit strong, but it is a very complex problem because, think about the difference. When you learn a second language in L2, the process is pretty binary.
Binary how?
You have your native language, your L1, and you have this new thing you're learning. So if you're going to lean on what you already know, which we all do, you only have one place to borrow from.
Right. You copy-paste the rules from your native language, which is exactly why my Spanish sometimes sounds like it has English grammar.
Precisely.
Yeah.
That's what we call transfer. But now, just imagine you're starting a third language.
Okay.
Suddenly, your brain has options. Does it copy from your native L1, the language you've known your entire life? Or does it copy from that L2 you crammed for in high school?
Or both. Or neither.
Or both.
Yeah.
Exactly. There are at least 4 possibilities. And the research we're focusing on today, especially a theory called the Typological Primacy Model, suggests your brain is not just guessing. It's running a very specific, subconscious algorithm to decide which rules to steal.
Okay, let's unpack that. Because the sources lay out a few competing models, and they start with what feels like the most obvious one, the default L1 scenario.
Mother tongue theory.
Basically, that your native language always wins.
Right. This is the idea that the L1 is just too dominant, too established to ignore. It's the foundation of your entire cognitive house. So, of course, your brain would default to it.
And there's a study on this.
There is. One by Hermas back in 2010. He looked at speakers of Moroccan Arabic. That was their L1, who also knew French as an L2.
Okay, Arabic first, French second.
And they were all learning English as their third language, their L3.
So what was he looking for? What was the tell?
He looked at where they put their adverbs. In English, we're pretty strict, right? We say, Lucy does not play chess. The adverb comes before the main verb.
Sure.
But in both Arabic and French, the structure is more flexible. You can have the adverb after the verb. So you might get something that translates to Lucy plays not chess.
Lucy plays not chess. Sounds a little Shakespearean.
Or a little Yoda. Plays not chess, she does.
Huh, right. So what did the learners actually do?
They consistently use that other structure. They were saying things like, Lucy plays not chess in English. So Hermas argued this was proof. Proof that the L1, the native Arabic, was the default filter for the new language.
But hold on, you said French does the same thing.
And that is the big catch. That's the flaw in the argument.
Right.
You can't say for sure it was the Arabic influencing them.
It could have just as easily been the French.
It could have been. Or, and this is a really important counterpoint, maybe they just hadn't fully mastered the French rules yet. So their brains had no choice but to fall back on Arabic, the language they knew best.
So it's inconclusive. It's like blaming your parents for your bad habits when it might have been your college roommate.
That's a surprisingly good analogy. And because of that ambiguity, researchers started looking for a different answer. Which brings us to the L2 status factor.
Okay, the L2 status factor. Some people call this the freshness effect, right?
That's right.
Now, this one feels a bit counterintuitive. This theory says the second language is actually more important than your native one.
Yes. The theory, which comes from researchers like Bartle and Falk, argues that the L2 has a special privileged status because of how it's stored in your brain.
How so? What's the difference?
It's all about memory systems. Think about your native language. You didn't learn it in the classroom, you just acquired it. It's in what we call procedural memory.
Like muscle memory.
Exactly. It's like riding a bike. You don't consciously think about conjugating verbs in English, you just speak.
Right, I just open my mouth and the grammar kind of happens.
But any language you learn later in life, your L2, your L3,
yeah,
it's usually stored in declarative memory. It's more conscious. You have to think about it. The theory is When your brain starts in L3, it goes, okay, this is another foreign language. I should look in the foreign language filing cabinet.
That makes so much sense. So it's like, I'm in learning mode. Let me go to the part of my brain where I store things I've learned, not the deep instinctual part.
It bypasses the L1 because the L1 is in a different format, so to speak.
Huh.
Bartle and Fall tested this in 2007 using something called the V2 rule.
The V2 rule.
It stands for verb second. In Germanic languages like German, Dutch, or Swedish, the verb must be the second element in a main clause. It's a very strict rule.
Which English doesn't have.
Not anymore. We're much more flexible. For instance, you could say, yesterday I ate an apple. The subject I is second. The verb ate is third.
Okay.
In a V2 language, that's illegal. You have to say, yesterday ate I an apple. The verb has to be second.
Yesterday ate I an apple. Wow. Okay, that sounds very old-timey.
It's related. So they took learners who were studying Swedish or Dutch. Some of them had a V2 language as their native L1. Others had learned a V2 language as their L2.
Ah, I think I see where this is going.
And the results were striking. The people who had that V2 rule as part of their second language were much better at transferring it to the new language than the people who had it as their native language.
No way. So even though the native speakers had used that rule their entire lives, the people who learned it later were better at applying it in a new situation.
It suggests that because that L2 knowledge was fresher or stored in that more accessible declarative system, it was easier for the brain to copy-paste. The brain prefers the foreign language file over the native instinct file.
That is wild. It really pushes back against that native is best idea. But there's another theory here that sounds a bit more optimistic. The Cumulative Enhancement Model.
Yes, the CEM. This is what you might call the helpful brain theory.
I like the sound of that already.
The core idea here is that the brain is smart. It doesn't just blindly copy from the L1 or the L2. It scans your entire linguistic inventory and asks, what here is going to help me? It's all about facilitation.
So it cherry picks. I'll take a little bit of this syntax from French and maybe some of that vocabulary from Spanish, whatever works.
That's the idea. There was a study by Flynn in 2004 with Kazakh speakers. Now, Kazakh is a head final language. The verb comes in the very end of the sentence.
So like, I eat apple ate.
Exactly.
Yeah.
But these Kazakh speakers also knew Russian as their L2. And Russian is head initial, just like English.
Yeah.
I ate the apple. So when they started learning English as their L3, you'd expect them to struggle, right? Their native grammar is basically backwards compared to English.
But they had Russian in their back pocket.
And they used it. They picked up the English word order surprisingly quickly. The CEM argues they just bypassed their native Kazakh altogether to use the much more helpful Russian structure.
That sounds great, but I have to ask, if the brain is so smart and only picks helpful things, why do we still make mistakes? Why do I transfer rules from Spanish to French that just don't work?
And that is the fatal flaw of the Cumulative Enhancement Model. It has no good explanation for negative transfer.
Right.
We know for a fact that learners transfer rules that lead to errors. If the brain was really just scanning for what's helpful, it wouldn't do that. It would filter out the bad stuff.
Which brings us to the main event, the theory that our sources focus on most heavily, the Typological Primacy Model, TPM for short.
This is where it gets really interesting. The TPM, developed largely by Jason Rothman and his colleagues, argues that the brain doesn't care about L1 versus L2 status. And it doesn't only care about what helps.
What does it care about then?
It cares about typological proximity.
Typological proximity. That is quite a mouthful. What does that mean in plain English?
Similarity. The brain acts like a computer parser. It scans the new language you're hearing and compares it to the languages you already have stored. And it asks a very simple question. Which of my existing systems looks the most like this new one?
And when it finds a match?
It copies that entire system, wholesale.
Wholesale. You mean it takes the entire grammatical structure and just dumps it onto the new language?
That's the argument. And this is the crucial part. It happens subconsciously. You don't choose to do it. Your brain essentially concludes, okay, this new input looks a lot like Spanish. I'm just going to run the Spanish software to process this.
That sounds incredibly risky.
It is. But it's also cognitively cheap. Think about it from an energy standpoint. Is it easier to check every single grammatical rule one by one to see if it fits? Or is it easier to just assume, hey, this looks like Spanish, let's just use the Spanish operating system and we'll patch the bugs later?
It's the lazy or I guess efficient choice, but how does the brain even decide what looks similar? If I'm just starting a language, I don't know the grammar yet, so how can my brain judge grammatical similarity?
That's a great question, and the TPM proposes a specific hierarchy of cues, a kind of checklist. And the very first thing it checks is the lexicon, the words.
Vocabulary.
Yes, if you start hearing a language and you recognize a lot of the words, maybe they look like English words, for example, your brain immediately flags English as the probable source.
Oh, okay, cognates. That makes sense.
Exactly.
Yeah.
If the words don't help, maybe you're learning Japanese and nothing sounds familiar, it moves to the next level. Phonology, the sounds. Does the rhythm and melody of this language sound like something I know? And only after that does it look at deeper grammar.
So if I know English and Spanish and I start learning, say, Danish.
Your brain will hear the Danish words, it'll realize many of them are very close to English words, and boom, it selects English as the base template. It will start applying English grammar rules to Danish, even before you've actually learned Danish grammar.
And that's the wholesale transfer. It's an all-or-nothing deal at first.
In those initial stages, yes. Rothman calls it a blunt instrument. The brain makes one big sweeping decision to economize its effort.
So how on earth do they test this? How do you prove the brain is copying a whole system and not just picking and choosing rules?
They use a really clever setup called a mirror image design.
Okay.
Imagine you have two groups of people. Group A are native English speakers who learned Spanish as their L2. Group B are native Spanish speakers who learned English as their L2.
Got it. So they know the same two languages, just in a different order.
Exactly. Now, you teach both of these groups a third language, Brazilian Portuguese.
Yeah.
Now, structurally, Portuguese is very, very similar to Spanish. They're both Romance languages, not very similar to English.
Right.
And the result, both groups transferred rules from Spanish. It made no difference if Spanish was their L1 or their L2. The brain looked at Portuguese, saw the resemblance to Spanish, and just activated the Spanish grammar. Typology, that raw similarity, it beat both the mother tongue bias and the freshness bias.
Wow. That is very compelling. But does it explain the mistakes, the negative transfer we talked about?
This is the strongest piece of evidence for the TPM. I'd call it the smoking gun. A study by Rothman and Cabrelli-Amaro in 2010. They took English speakers who knew Spanish as an L2,
Okay.
and then they had them learn two new languages, Italian and French.
Okay. Italian and French, both Romance languages, so they're in the same family as Spanish.
Correct. Now let's look at one specific rule. Null as subjects.
Null subject.
It just means you can drop the pronoun. In Spanish and Italian, you can say comemos for we eat. The we is optional. It's understood from the verb.
Right. But in English and French, you can't do that. You have to say we eat or nous mangeons. You need the nous.
Exactly. So for the learners who were tackling Italian, transferring the rule from Spanish is great. It's helpful.
Facilitation.
Yes, both Spanish and Italian let you drop the subject. But for the learners who were tackling French, transferring that same Spanish rule is a disaster. It leads to errors.
Because French, in this one case, acts more like English.
Precisely. So if the brain was using that helpful model we talked about earlier, the CEM, it should look at French and say, oh, wait, my native English has the right rule for this. Always use a subject. I'll use that one.
That would be the logical, helpful thing to do.
But that is not what happened. The learners transferred the Spanish rule to both languages.
To both, even when it was completely wrong for French.
Even when it was wrong. They started dropping subjects all over the place in French. They were saying things like mangeons instead of nous mangeons.
So they literally had the correct rule available to them from English, and their brain just ignored it.
It ignored it. Because on a holistic level, French looks and sounds like Spanish. The brain's parser said, this is a Romance language. Load the Spanish software. It prioritized that overall system similarity over the accuracy of any one specific rule.
That's actually kind of funny. The brain is so convinced it's found a shortcut that it drives the car right off a cliff.
It's a fascinating inefficiency in the name of a larger efficiency. The system match is more important than the rule match, at least at first.
So we have the TPM saying the brain uses this blunt instrument, copying whole systems. But surely there are other researchers who think the brain is a bit more refined than that. I mean, we're not totally helpless.
Oh, absolutely.
Yeah.
This is science. There's always debate. There's the Linguistic Proximity Model, or LPM.
And what's their take?
They agree that similarity is key, but they strongly disagree with the wholesale part.
Okay.
They argue the transfer is piecemeal. It happens property by property.
So bit by bit.
Yes. They say the brain is capable of checking smaller clusters of rules and transferring them individually instead of just dumping the entire system all at once.
And then there's the Scalpel Model, which I have to say just sounds cool.
It does. This is from Slabakova. She argues that the brain is precise, like a surgeon. It tries to identify and extract only the specific rules it needs from either the L1 or the L2.
But the sources we looked at seem a little skeptical of that idea.
They do. The main critique is that the Scalpel model, while it sounds nice, is probably very cognitively expensive.
Meaning it takes a lot of mental energy.
A lot. Being a surgeon requires a huge amount of knowledge and precision. A novice brain just starting in L3 doesn't know enough to be a surgeon yet.
You can't perform surgery in the dark.
Exactly. The TPM argument is that when you're a beginner, you don't have a scalpel, you have a sledgehammer. You grab the biggest, most obvious tool, the most similar-looking language, and you use that until you learn enough to be more precise.
So the scalpel might come into play later, but in the beginning, it's all sledgehammer.
That's the TPM perspective, yes.
So what does all this mean for us, for the person listening to this right now who might be trying to learn their third language?
It means we really have to rethink how we see our own learning process. We tend to think of it as building something from scratch, brick by brick. But this research shows your brain is actually trying to use a blueprint it already has,
It's an economizing machine.
a total economizer. It uses your past experience to interpret new data. And sometimes that leads you astray. If you're learning a new language, your brain is silently, constantly comparing it to your others. You might be making mistakes not because you don't know the rule, but because your brain has auto-corrected to the wrong language system.
That is such a helpful way to frame it. It's not that I'm bad at this. It's that my brain is so aggressively trying to be helpful that it's using the wrong map.
Precisely. And if you're aware of that, if you can figure out which of your languages your brain thinks is the similar one, you can actually start to predict your own errors. You can watch out for those specific kinds of transfers.
Before we wrap up, there was one thought in the source material that I found really provocative. We've talked a lot about the third language, but what about the fourth or the fifth?
This is really the frontier of the research.
Mm.
The TPM makes a strong case for this wholesale transfer for the L3. But does that keep happening for the L4? Does the brain eventually just learn how to learn?
Does the parser get an upgrade?
Maybe. Or maybe it just gets faster at finding the best match. But there is a real possibility that after you learn enough languages, the brain stops trying to copy these huge chunks and actually gets better at that scalpel approach.
So it stops assuming and starts analyzing more.
It could be that the more languages you learn, the less lazy your brain becomes. Or at least it gets much better at managing its own laziness. It becomes an expert system, relying less on brute force and more on nuanced analysis. But we need a lot more data on experienced polyglots to know for sure.
Well, to all of you out there working on language number 3, 4, or 5, pay attention to those errors you're making. They aren't just mistakes. They're clues as to which operating system your brain has secretly decided to run.
And don't be too hard on your brain. At the end of the day, it's just trying to save you some energy.
Thanks for diving deep with us. We'll catch you on the next one.